to come and bind here, it transcribes only 300. I'm just giving you an example of number. So do you think it can carry out its function normally? No. Or maybe you have upregulated. You know, upregulated means instead of 500, it transcribes it to be 800. It's over. Then what is required? That is also not factors that you have too much, it can go and bind randomly to other gene, other enhancer of other gene. That is now activate that particular gene. Other factors, like I said, this one, phosphorylation, methylation is a process to activate the transcriptional factor. Some other instances you have mutation. Right? Right? So now, when you want to activate this particular gene, this transcription factor, how this bind to the DNA of the enhancer? Hook. Discovery. I will cover that later. Okay, so this is one part of biomarker discovery. Okay. So transcriptional factor. Okay, what will happen here? Activated protein bind to the piece of enhancer. This activated protein, it will go and bind to the enhancer. When it binds to the enhancer, it causes the DNA to bind to bands. Means that bring them close together. Usually they are far from each other. So when these two bind together, it come close together. Why it come close together? So that other things can come and bind to them and activate the transcription. You understand? So now, okay. So the second one, other transcriptional factor protein may join the activator protein and forming a protein complex that binds to the gene promoter. So do you see the importance of transcription factor here? It forms a complex. Why do we need to form a complex? So that later RNA polymerase can go and recognize and sit on that complex. Okay. So when transcription factors fail to bind to the activator protein, it fails to form a complex. Okay, that is where it fails. Okay, so The insulator can also stop the enhancer from binding to the promoter if a protein called CTCF. Okay. So now you can have a transcriptomic that leads to proteomic. So now they are talking about CTCF. They say it's a protein, right? So this comes to under proteomic. But it's actually when you study the mRNA level, you may have a mutation at the CTCF or anything dysregulated that causes this CTCF to dysregulate. That maybe it is translated into the factor, it binds to other transcriptional factors to form a function. They bind together. They have an active recognition site. Okay, you do modeling, you will know this. Okay, where it binds, how it form a molecule. So when there is a mutation on the CTF, so this particular gene of interest cannot come and bind, cannot form a complex, cannot perform a function, dysregulated or upregulated. So one of the things that we can look for biomarker discovery is transcriptional factor. The function to regulate, I think I've covered most of it. To make sure group of function. Okay, like what I said just now, did I mention CTCF doesn't CTCF, the transcriptional factors doesn't just sometimes work on its own. It works as a group. So when it works as a group, it actually sometimes coordinate the cell division, cell growth, cell death. Like when you see the pathway, when you look at the pathway P53 sits somewhere here. P53 actually activates some other gene. And this gene activates some other gene. And then only it leads to apoptosis. Okay? So the failure of P53 to activate the gene, it will cause all the failure in the downstream pathway. Okay?
Yep.
So we have about 1,500 to 1,600 transcriptional factors. Transcriptional factors sometimes doesn't work alone, sometimes work alone, or sometimes with the other protein combination. I think I have to cover that. So the transcription factors are also of interest in medicine because mutation of transcriptional factors can cause specific disease. I covered as well. The mutation or anything that in transcription factor can lead to disease. So it can indirectly be an target of a treatment. It depends. When you do a biomarker discovery, why you do discovery? I think I want to have some interaction with you guys so that it's not boring and you don't fall asleep. And it's unfair, I'm older talking. So let's just talk together. Okay? So I'm throwing you a question, you have to answer me, okay? Why do you think we do discovery? If you volunteer, I will pick.
Because
Finding biomarker and like for diagnosing diseases.
Okay, you are there. You want to add?
because I think discovery is useful when we want to diagnose something or to use it as a therapeutic.
Yes. So sometimes the biomarker that you use is not just for discovery. Discovery is what? This person having a disease or not. There are a company in KL now. I can't recall the company name, but there is a company in KL. They use a platform like NanoString, high-end platform. So what they do, you know what they do? They recruit people, a group of population, and they screen their profile. When they screen their profile, they have a transcriptomic profile of a particular person. Okay, so when they have a transcriptomic profile of a particular person, now they segregate. This person is actually normal. Then now what they do? They get a profile of a breast cancer. They get a breast cancer patient, they group them, they study their profile. So when they study the profile of a breast cancer, so they know what are the molecules that is actually responsible for breast cancer formation. Okay, so now when you have a biomarker, you can actually go for screening, right?
Yep.
That's one thing, right? So biomarker is for screening. Another thing, biomarker is for prognosis. Prognosis means what? You want to see the response.
Response from the treatment.
Yes, when you want to see a response of a treatment, sometimes they use a biomarker, to see maybe when you have a good response, this particular biomarker should be elevated. They have a threshold that they have already studied from the previous population. They already have a data. So how they want to determine you is actually from their data. My mother was diagnosed with breast cancer 3 years ago. Then, luckily enough, she was detected stage 2 breast cancer. We used to have this annual checkup for her. Every year we bring her for annual checkup, and so when COVID we need it because it's not safe to bring. She is diabetic, high blood pressure, cholesterol. So I don't want to bring her to hospital and expose her, to the COVID, and later she will develop something else. So I missed 1 year. So when I missed 1 year, the next year I went and she was detected with lump. And when I went and did biopsy, it was stage 2 breast cancer. And I was not happy to do chemotherapy. You know why? Because she's quite old, she's 63. And she has this high blood pressure, she has diabetes, she has all other diseases. I do not want to give her chemotherapy that, later instead of enjoying her life, is deteriorating her movement, her life and all that, So I tried to omit the chemotherapy because it's stage 2, right? So what I did? Anyone can guess what I did?
One for immunotherapy.
No, I didn't do any of that. I just did radiotherapy for her. Sorry? Huh? What?
Lumpectomy.
Yeah, of course I did that. But of course, you did that. Okay, what does it mean by stage 2 cancer? Stage 2 breast cancer, what does it mean? Where does breast cancer has gone to? It has gone to lymph node, but it has not penetrated the tissue. Once it's penetrated the tissue, it's stage 3. Okay, so once now lymph node is positive, lymph node under armpit is positive. So I did mastectomy, that's normal. Okay, of course I did that. So how do I know whether she need chemotherapy or not? I sent for oncotype. I sent her biopsy sample to US for oncotype. You know what is oncotype? Oncotype is in US they have a data of expression profile of people with breast cancer stage 2 with chemotherapy, without chemotherapy, whether the risk and the benefit is less or more, and they come up with a score. This is one of the, what is it? In cancer, this is one of the prognosis. Okay, so if she gets score below 10, she don't need chemotherapy. If she gets score more than 10, she needs to go for chemotherapy based on the oncotype, based on the expression profile. So the expression profile, they look at the transcriptomic profile of those that has cancer that went for chemotherapy, whether it benefit them or it risk them. Okay, so less than 10 means that the benefit and the risk is more or less the same. So why should I risk her when the benefit is more or less the same? So I omit chemotherapy. Do you see the usefulness of transcriptomic? To determine what type of treatment you need, whether you want to go for the treatment or not. They group those transcriptomic profile. You know what I mean?
Yeah.
So now, that is one of the usage of biomarker. Another one is, what are other things? Treatment to the respond to the treatment. Okay? So that's why we need to study biomarker for all these things. And it depends. You want to do in transcriptomic, proteomic, or genomics. It depends on the disease state. It depends on the sample that you have. It depends on the expression pattern that you are looking at. Okay? Okay. Transcription factor protein that binds chemical modification. Okay, so when you want to have a gene activated, one of it is, I said, you can have it by binding with transcription factors, right? Another thing you can have maybe like chemical modification. Chemical modification, like what I said just now, the packaging, phosphorylation, demethylation, and all that. Then you can have also a splice. What is alternative splicing? Anyone? I want to know your basic. Did you learn in degree?
Yeah, splicing is when you transcribe the DNA, RNA, then it's not contain some intron and other stuff, so you splice that. Cut the useful, not useful introns.
Okay.
Make sure the exon is
set. Okay, so now in RNA you have a coding and non-coding, right?
Yeah.
Okay. So what do you think is important, coding or non-coding?
Coding.
Do you think non-coding is important?
Yes, I think it's also important.
Nowadays, like they found it's important for biomarker and
depends on what aspect you're talking about. If you're talking about mutation, of course, non-coding regions is also important to protect the.
So do you think coding RNA can be used for biomarker as a biomarker?
Yes, like I think like right now they are using for cancer biomarker, for example, like small And then like small, yeah, I think small RNA, this one, and
MicroRNA.
microRNA, yeah.
The famous one now is microRNA because microRNA is being secreted in the blood.
Yeah.
So you have a non-invasive type of maybe diagnosis, or or maybe what you can say, what's the word? So like you want to monitor the response. Sometimes you give a chemotherapy drugs. For instance, you give a drugs to the particular person. You want to see after 3 months, after 6 months, how is the response. You want to withdraw the blood. You just withdraw the blood, right? Withdraw the blood and you just check the microRNA profile. So microRNA is a non-coding RNA.
Yeah.
So microRNA can also be one type of biomarker.
Yeah.
Okay, just now I've already covered transcription factor. Now it's microRNA. You also have other type of RNA. That I will cover later. That can also be type of biomarker. It's depending on the disease, whether that the dysregulated or the malfunction of that particular biomarker leads to disease or not. It depends. Okay. Okay, so now we go for alternative splicing. In gene, like what you said, you have a splice, you remove intron, you have an exon. So you combine exon together, you have a functional mRNA. Okay? So that is alternative splicing. But in alternative splicing, you can also have a truncated version. A few truncated version of alternative splicing, which means that in one particular gene of interest, you can have a combination of exon. The combination of exon will give you a different of type. You get what I mean?
Yeah.
But it's under the same gene. But maybe their function a bit different. So this give more complexity in the biomarker. That or not?
Yeah.
You already have one gene. So you don't talk about one gene. For example,
It's insulator. The
insulator can stop the enhancer from binding to the promoter if the protein called CTCF binds to it. Okay? If CTCF binds to it, it can stop these two together. But what if CTCF supposed to bind? Supposed to bind to stop these two together, but then it didn't bind. You know why it didn't bind? Because it has a brother that can integrate or interact its function. It is called Boris. CTCF and Boris is actually analog. They are about 99% similar. 90 to 99% similar. Okay? The only difference of CTCF and Boris is in the gene domain. Okay, when you have a gene, not affected. Boris, they have isoform. They have 21 form. Into 5 family. You can see, right? S1, this I just give you example. I can't give you example of all the genes. I go detail in one gene, you try to relate the other genes of interest. Okay? So now Boris, they have 6 isoforms. 6. 5.
I thought you can.
6. 6. They have 6 subfamily, which means that 21 isoform is being grouped into 6 subfamily. When you look at the
Yeah. I just give it. Yeah. Like, yeah, because you want to see whether this gene is overly expressed or.
Okay, none of you are correct. You know why? I give you a sample. If I give you this particular cancer, I think it's because of this isoform. It's because of this Boris that caused this cancer. I have to study what isoform is actually expressed in this cancer. You don't know, right? You have 6. You don't know. So if you use microarray, there are chips. You are actually putting your things on the chips. So if let's say the chip doesn't have Boris, do you think you are actually discovering something from the microarray? No. Real-time PCR, you have to design primer.
Yeah.
Right? So when you have to design primer, you have to design each primer of this. It can be, but it will be too laborious. Okay, it will be too laborious. Like how you want to study 21 isoform with 21 primers. And sometimes the most complicated thing is not all isoform is being clearly identified in NCBI. These are quite new.
Okay.
This isoform discovery is quite new. So when you use a primer, to design to do real-time PCR, sometimes your biomarker may be incorrect because the full complete of information is quite missing. So the best part is RNA sequencing. Okay, so RNA sequencing, that's where it comes with novelty finding. Because this is quite novel, I mentioned to you. So you have to know when you do a platform analysis later on, whether you want to search for novelty or not. So if you're looking for something novelty, microarray is a big no. Because something is already there and you're just putting something on it to see the signal is red or not. So you are just saying benda tu ada ke tak ada, yes or no. Okay, so when you do RNA sequencing, you are actually going and dig what it has actually. Okay, then from there you do a bioinformatic analysis and all that, then bingo, you can discover few things inside there. You follow me?
Yes.
So this isoform is one of the biomarker. Okay, so just now I cover transcriptomic factor, transcription factor. I cover that is transcriptional factor. What else I cover? Non-coding. Non-coding. But actually non-coding I will have a lecture later. Okay, wait, sorry. I think we need a break or later. Okay, we need a break for prayers. Okay, so the non-coding and the next one is isoform. Isoform, it can be also used as a biomarker. Okay, these isoforms. Okay, maybe you have this isoform expressed, this isoform is not expressed in this particular cell cancer, that particular cancer no isoform. All that thing can be a biomarker for you to differentiate between what is the disease state, non-disease state, what are the disease A, what are the disease B. So that is biomarker. You want to differentiate, you want to classify this thing. Okay. Okay, just now I mentioned about coding and non-coding, right? So coding is mRNA. Non-coding can be microRNA, siRNA, all those things, okay? Okay, the most important thing is history. And non-coding RNA is a large segment of RNA. They have been verified to have important tissue-specific expression, various interaction. Some of the non-coding RNA involved in this particular process, okay? Novel non-coding have a potential function in cancer biology. Non-coding RNA can be used as a biomarker, like what I mentioned just now. Okay, so you must know what are the non-coding RNA, and that non-coding RNA is actually responsible for what function. Okay, here I have a detail, not so detailed, but a bit of information. Like, you know, small nuclear RNA, so the nucleus is involved in the splicing and RNA processing. So when the splicing doesn't take place, when you talk about the isoform that you want to discover as a biomarker, like I mentioned just now, so when small nuclear RNA is not functioning, then the splicing cannot take place. So when the splicing cannot take place, you know, you will have a dysregulated in the isoform formation. When this dysregulated in isoform formation, maybe it will lead to disease. So you must know what you are studying. Okay. So the extra RNA, small, microRNA. So all these things is just a function of each particular non-coding RNA. You know, these are the non-coding RNA. So this plays important role in function. Like what I mentioned, among all the non-coding RNA that I've mentioned, the most important and the famous one now being used as a biomarker is microRNA. Why microRNA? There are a lot of lists of microRNA that has been classified in the research. That if you can see, they have already classified few microRNA for the certain type of disease. Okay. Why we use microRNA is because it's not invasive. It's been secreted in the blood. It's easy for you to get. You don't have to do biopsy. Biopsy can be quite painful, right? So it's easy, it's from the blood. Okay. It plays a role in like microRNA. It has a function in proliferation, differentiation, apoptosis, metastasis, we know drug resistant. It can be tissue specific. MicroRNA is a very tissue specific. So now when you use microRNA as a biomarker, it doesn't cross with another microRNA because it's specifically only expressed in that particular tissue. So that's why it's one of the important criteria of biomarker discovery is tissue specific. You know, it's only expressed in that particular tissue of interest. Okay, if you're talking about mutation of this particular biomarker in other cancer, other cell, you don't have that mutation. Only in this cancer you have that mutation. Then only you can use this particular gene as a biomarker for that cancer. You got what I mean? You follow? Okay, like what I said is liquid biopsy. That's why they prefer microRNA because it's liquid biopsy. Suggested to relieve due to the passive leakage in apoptosis. It releases to the blood. MicroRNA related to the degree of tumor progression present differently at different stages of cancer. So what people do, microRNA, people see the stages of cancer. Stage 1, stage 2, stage 3. Why is it important to know the stages of cancer so that you will know what type of treatment to give? Okay, that is one of the aspect or the importance why you do this biomarker. Okay. This is just a microRNA that I mentioned. Okay, so like I said, some of the literature search, if you do, even when you do your assignment later, you can find some of the researcher, they have already started classifying microRNA into certain type of cancer. Like now, you can find microRNA 146A, linked to what cancer? Like liver cancer, this cancer. So it's specific, it doesn't cross the other cancer, okay? So why do you study the gene of interest? To understand the functional activity, how they are regulated, how they respond to the physiological changes, to understand the protein that this gene may encoded. Why is it important? Because sometimes protein function is different compared to the gene. I think I put some break, okay? So we're going to break later a bit more, okay?
Yeah.
Okay, biomarker identification. So you do, I also covered already, do diagnosis, monitoring, treatment response, development of preventive therapies and cure. Okay, so this is the disease pathway. When you have a disease, you want to do a screening, diagnosis, you want to do a pathogenesis study on all that, prognosis, you use this biomarker. And these are the type of biomarker that have already been classified and has been used previously in cancer treatment, BRCA1 mutation, that is for breast cancer, for prostate, and you have 21 genes for breast, KRAS mutation, for anti-EGFR treatment, So you have all these specific type of cancer. So now when you do research, you want to look for novelty. What are actually you're looking for? Why you study cancer? Why you do cancer research? Okay, now when I say, people already have BRCA1 mutation, then why are you studying it, breast cancer? Why you do research?
Because there's still many other subtypes that's not discovered yet. So for us to do research, first to find something novel, to see
Why other? You want to say something?
Like to fill in that gap that BRCA1 cannot, give the evidence that this person have cancer or not. Sometimes, I think they found they have BRCA1 but doesn't have cancer, or
It's not that they don't have cancer. Cancer haven't progressed yet.
Yeah. So
that's why it happened to Angelina Jolie, right?
Yeah.
So mother has breast cancer. She went and checked herself, and she has what? It's present, but she doesn't have breast cancer. How she knows? She went into screening. She did genetic screening. So it doesn't mean that she doesn't have. It doesn't happen yet. It's not the time yet. It will happen when it has to happen. So why you do again the cancer research? Why do you do this? Because one of it is because you want to improve the treatment. How do you improve the treatment? The chemotherapy drugs works on that particular gene of interest, right? So now when you have a BRCA1 or whatever, P53, so that drugs will work on that particular gene of interest. And chemotherapy, people are resistant to chemotherapy drugs. And sometimes chemotherapy works for all the patient. That's why now they do what? Personalized? They do personalized medicine. They personalize the medicine for you. Because they want to know you are actually susceptible to what disease. How is your expression profile? Your expression profile, even though this person has a breast cancer, another person also has a breast cancer, their expression profile is totally different. So when their expression profile is totally different, this person may be more responsive to the treatment compared to this person. That's why we do a personalized medicine to cater this particular person. So you do research again. It's actually for the improvement of the drug. You want to see which drug is actually works better instead of maybe you have a chemotherapy drug. temozolomide, you have one particular drug of interest for that particular gene. So you want to improve the drug. So sometimes you improve the activity of the drug, you put more functional group, you activate the drug, you put OH group, you put N group, you want to make it the drug more stronger to target a particular gene of interest. Or maybe BRCA1 is no more relevant. Maybe there is another gene of interest that causes more progression of the cancer. So you also have to know, progression of cancer is not just apoptosis. Cell addition, cell migration, cell invasion. There are a lot of things, right, that can lead to cancer. And all the whatever that I mentioned is actually being responded by different type of gene. When you have cell migration, or when you have cell migration, gene A that causes it. Cell invasion, gene B that causes it. Apoptosis, maybe say gene C. All this person has cancer, right?
Yes.
But you don't know what is actually the failure in that particular person's body that leads the person to have cancer. That's why you do again research and research and research, non-stop research, because you want to improve, you want to do a personalized medicine, you want to understand, or maybe this person, the invasion is actually the problematic that can lead to cancer. So we have to target the drug that can target the invasion, not just a general drug. You get what I mean?
Yep.
Are you clear?
Yes.
I need a break.
Yes, please.
I need water.
Okay.
Okay, so I think it's time for Maghrib. Yeah. We break for Maghrib. Shall we be back? How long? Okay, so later I just give you a heads up. So later we're gonna go for biomarker developmental process. How do we really go through a process to discover a biomarker? Okay, not too detailed, a brief one. Okay, so you have a discovery, analytical, validation, evaluation, clinical utility, clinical use. How do the biomarker can be finally used in a clinical and all those things. Then I will end my lecture. Any question?
No.
So far can follow my lecture?
Yes.
I hope you don't come back rosy later. Go and fresh up yourself. And we shall meet later. Where you guys stay? Inside or outside?
Outside.
Outside.
All of us are outside.
All of you outside.
Yeah. No one staying outside.
后给我们那个列表，然后在想去做之前要决定要不要开始你的研究项目。那说可能就往一选，就是他你得给他个就这样，research 你的
是，因为你要是要选，比如说你在第二个学期就开始你的研究计划的话，你要交钱。所以说你要决定你要在哪个时间开始的话，你就要在那个时间要注册开始。要选的话要交那个钱才能做那个实验，你没交钱就不能做实验。
没有，不是因为我们的学费是跟着那个credit hour算的，就是这样，就是你没有去交学费，你没有交学费的话，那你就不能开始。
对啊，所以就是你要开始，你要第二个学期选，第三个学期选，然后你在注册的时候应该就要选上一个课程，然后把取掉。
那个毕业设计是24个credit hour，你自己承担你的学费多少钱？我们的话好像是400亿，可是外国生好像多少美金？400亿是哪一天的？400亿，我们那可是
24小时400。
啊，
你说24，
我们是400亿，你们不是400亿，
你们一分是多少钱？
你们自己去算有多少钱？
不是，我们总共是多少钱？40、50、
按学分算起来，
那不然？
什么是按学分？
不是学分，学的那个
就是
计时
课程
课时嘛，课时按那个课时
就是学分，就是学分，
就是学分。
我们那 的水分。
什么叫它水分小小？
它这个全貌是4，我们总共水分是50还是40来的？所以这个应该是占了1半的水费。对。
什么？
对，他印象深刻，刻在他的。
他在勾引我。MC 看，我操！这个桌子太行了，
啊，好，我以为还做
MC 看。哪个
清淡的东西？
还是清淡的东西？你病了吗？还是应该你可以加白，
应该是这段时间睡得太少。
你可以加白饭，也可以清淡。
白饭都是糖的，哪里清淡？
白饭加水，
都是糖，
用水冲掉那个糖。1月10号有日。你要吃鸡蛋，怎样吃哦？不吃哦。
吃呆了。
吃带鸡蛋吗？吃带最够力了，我跟你讲。那些猪肉更加够力，我跟你讲，猪肉的
拿过。
对呀、猪肉的热量还比平常的肉热量更高一点。1月10号就嘴炮了。
什么关系什么东西？
对呀、你去那个印度面叫那个蔬菜水。
是哪一家？上次那家比较远的那家。啊？比较远的那家。
10分钟。它那个轮廓是什么轮廓？
上分就是写一个什么 platform 嘛，应该是你检测平台吧？我是这样的写的吗？就是不知道他要我们discuss关于什么的版头。
这个轮廓不是上分吗？你2有上分。
它是以后的算分，2是这种算分。
就是你要做的菜。
还有节奏太。一个题目。下次怎么着？
哇，还要明年才能请我，真的是。我列个表。
你哪位
啊？啊！那是你姐。
你们今年是好不了，
那是你姐。
明年看看有没有机会吧。
你那个表都没有带上，你还要跟他好几个？好带不上。
而且来我们家吃饭要吃大菜。
可以啊，对啊。
我还可以用什么腿？
我们马来西亚就可以做饭，
用手拿它这个是我们对啊，正好我们主吃。
整锅都是我们的。1月10号那个。还是你的？哦，还没有给。不是有你的翻译，你说要干嘛？翻译不准，而且他没给我翻译不出来，我就说不对。你都没有邀请我，你还给我请好吃。
我请你去，我也不做菜啊，不是我做呀。
没事啊，我可以吃啊，可以下面吃啊。对啊。
谁做呀？谁做的？
我可以做，我可以做的。
你的姐妹可以做。
啊，你的姐妹可以做。啊，做还要做。
你们出锅就好了。
会一些菜。红烧肉还没有，红烧肉那么难。红烧肉讲不好很难。
我也觉得不难。你们那个直接做到什么可乐排骨，或者是直接在可乐炒。可以啊，那你们要一样的，它都是一样的。可乐排骨怎么炒？
我买给你。
一样的呀，我觉得是一样的呀，对吧？它只是代替了那个糖化，就是给它上色。然后有一点点牛肉。可以做，你就可以做其他的呀。什么可以做好是吗？像你做什么啤酒鸭，你可以做啤酒排骨、啤酒鸭都可以做啊，一样的。
关键我做法就是理论上是一样的，谁要做出来？
你还会做烧肉？你怎么做？
简单的呀，就
拿回来烫了一下，我把那个都没有炉子，我这里没有做啊，这里对啊，在家里有做啊。这是一个唯一比较讨厌工具的东西。
这么讨厌工具？
枸杞也可以啊，猪肉其他都无所谓，其他猪肉基本都可以。猪肉来拿那个锤那个冲出来，然后给它涂一层麦芽糖，然后烤了过后再给它涂一层麦芽糖，你那是正常的呀，做出来就可以，直接做出来好吃，你就不会剩。你可以做的不是。这样子，这样子，你们就能在年前就恢复你的生活。我年前不行，年前没写完作业，年前做不了了。他们怎么都施工了，都去祈祷。记得是一会儿知道，记得你的海鬼就给我们好的，就不得。这个你要考验超出范围了，超出范围了。吃爆雷了，我的排骨都是高压锅炖的，有高压锅配个冰淇淋。那你只能祈祷我不出错吧，玩不出来。
你做糖醋里简单，你过个油，
不
焯简单，过个油，然后再裹着那个糖醋酱。
这简单，但是我没有做过，我只做过糖醋。我只做过糖醋打鸡翅。
这跟糖醋有什么区别？不就是把话梅扔进糖醋里面一起泡而已吗？对啊。啊，我知道了，挑战一下做姜母鸭。我感觉姜母鸭比较讨厌。
我只做过2个多月的饭，没有那么小水平。
挑战自己 ，OK？ 什么刘先生什么都没有学会，继续没有做。
我做这个之前，你排骨煮，你得煮得好，不能煮成那种今天就选都选好，不能选那种咬硬。
我没有做过这个体验，所以第一次吃。我觉得，因为其实你讲做出来味道不像，你只是调味方面的问题，也是要把握。还有那个还没有这个。你到底有没有煮过饭？做过什么？啊，这个东西要跟我们这边一套菜叫巴黎排骨，然后就是把它放多少？太考验了，
就按标准放。
你妈咪哦。
可是妈咪排骨没有这么麻烦，因为本身那个妈咪酱也是调好的。
对，
那个酱也是调好的。
这个东西呢，它的技术的难度是在于怎样去调那个酱的，调那个酱需要你要讲是那个酱，因为那个酱考验你的火候和你的那个口味的，这个比较难一点。可是我觉得这个做多几次，你就做得出你自己口味。你要一直做吧，不能。这一下他的朋友。你才做饭。但你的东西也不多吧？空气炸锅。
这些真的属于好吃菜的主力。空气炸锅它都不能自己控制，体现不出它的技术。 东其实是用灭了，那我们用柴火的这种死灶，打东西是有灭的，最麻烦的是控制火候，有个教材的那种。现在知道了，可是为什么我只因为外国人喜欢吧，我看过一个好笑的东西啊，我看他拼命把那个东西的是什么味道可以啊，也有人用辣椒酱配啊，一样的道理，拿辣椒酱配导致配面包。斑马招式，下午这个
但是哦，想吃一顿饱的，
车内的优势，只要换，
可是你要吃单吃，
到家
好清淡啊，那个，他好清淡哦，我的天哪！
大多东西可以吃啊，你不一定要吃东西，东西给上这个家，大多东西久远。把在下一点点，
开车，
开车才是底气方面。不开车我连经济干。可以。不知道。
Sign for this.
那我不是，我绝对会的。你把每个阶段都定在你今天做完这个实验，晚上就对吧？晚上就那样。那你的意思就是用动作写你，但你就可以很快的，你每个可以做完，周末就可以做完。我喜欢做，然后做到是正确。不能用在那个
Yeah.
So we're going to go in the second part of the lecture. It's not going to be too long.
Yeah, also,
I guess I'll leave open doors.
no, we got assignment, I need to go back.
When you have to submit.
Like we have 3 assignments on coming 3 days.
It's okay, you have time.
I always tell myself I have time. But I always don't have time.
But my assignment, you have a lot of time.
I don't think so.
But because in this period,
How about, okay, never mind. So let me just explain about my assignment. We try to finish our class by 8 today, okay? Okay, so now, excuse me. Yeah. So, second part of my lecture, okay. Okay, so your assignment will be, we're gonna have, I just explain the assignment first so that you won't get confused. Okay, these are the platform that I will cover in Tommy. One of it is RNA sequencing, nanostring, and another one more is real-time PCR. Real-time PCR the baby cover, right?
Yeah.
Okay.
So
So
already.
okay. So now RNA sequencing, microarray. Okay. So just 3. Okay. Microarray, RNA sequencing, nanostring. Okay. When you do a biomarker discovery, you have a discovery and a validation. Okay, when you study a paper, you have a discovery, you have a validation. When you do a discovery, you have to use one platform. When you do a validation, you must use a different platform. You cannot use a same platform for these two processes. I repeat, for a bio-discovery process, when you want to discover a biomarker, when you have a complete set of patient sample, you want to discover a biomarker, you use platform A, discover. So now from platform A, you know this to be a potential biomarker. You want to confirm whether this is actually really a potential biomarker in this disease. So what you have to do? You have to do validation. Validation means that you have to use independent sample set. You have to have another group of sample to test whether this particular biomarker is really exists in this particular disease using a different platform. So now, I will group you guys into 3 groups. Group A do microarray. Group 2 will do nanostring. Group 3 will do RNA sequencing. It's individual assignment, but you will just share a platform. Okay. When you choose a platform of these 3, bear in mind when you do a literature search, they will come into a validation using another platform. Another platform using people do is real-time PCR. So when you do a presentation later on, you have to also cover on the validation using a real-time PCR part. Do you read what I mean? Sometimes you will do a discovery using nanostring, but you are too rich. You have so much money. I can throw the money for another RNA sequencing. I can throw the money for string. Because 2 big platform for the biomarker discovery and validation is also fine. So it depends on the platform. The first platform, the discovery platform, that is the platform that I give you. Okay, so when I give you a discovery platform nanostring, make sure you present on the nanostring for the discovery. Validation can be any platform. Do you get what I mean?
Yeah.
Okay, so now, how many you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 3. You nanostring, nanostring, nanostring.
Okay.
Okay, RNA sequencing, RNA sequencing, RNA sequencing. Okay, microarray, microarray. Okay, microarray, microarray, microarray. Okay. What does it mean? When I give you nanostring, so sorry. I'm so sorry. I'm so sorry. I'm so sorry. I forget you guys. Let me see your face.
if there is no assignment for them.
Yeah, where is your face? Show me your face.
No, expand the window.
Who's the COVID positive face? Where's the COVID positive face? How to expand?
The arrow.
This one, right?
No, click on my arrow.
This one.
Yeah.
Oh. Who's the COVID positive? Are you COVID positive? Where is it? Me. Never mind. Oh, you. Alah, kesian you. Are you okay? Can you follow? As if you are sitting in your father's library, am I right? Is this
her own library.
oh library? Wow, you must be a very hardworking. You have so many books. Is this your book from your primary school, secondary school? You collecting? Yeah.
Yeah, Kavita.
You collect all the books, is it? During your school time? Children. Oh, children. Oh, she's married. Oh, okay, I'm seeing all. Your mom's off? 2 children, is it?
No, at work.
She's at work.
Yeah, she's working.
Oh, she's working. Okay, okay. So you're working as what, Kavita? I cannot hear you. Is it? Or scientific officer. So what about you? She's Malaysian?
Yeah.
She's at home?
Yes.
What she type? Okay, never mind. So Kavita, you do on nanostring. How do I address another person? Yo, is it?
Yo.
Yo. Yao. Okay. Yao, you do on RNA sequencing. Okay?
RNA sequencing.
Yes. You get now? Okay. So now, let me see now. Okay. So how do you do your assignment? You have a report and you have a presentation. When you do a presentation, when you do a report, written report, you have to write me a platform. No copy and paste.
Oh.
If I detect you copy and paste, I will plagiarize you.
Copy what?
No copy and paste in your written report.
In between
Do you know what I mean by copy and paste?
plagiarism.
Yes. Do you know how many percent?
20.
If detected, you are considered as copy and paste?
20. I don't know. Like for you. It depends on you.
If I find more than certain percentage,
20.
20%, okay, then I will get you, I will minus your okay, in your report. And assignment, my assignment can reflect a lot of marks. Okay, make sure you do properly, okay? I will screen in plagiarism platform. I will use a software to screen your report.
Let me hear.
I don't know which platform, but I will screen and I will give you the report if you are detected plagiarized.
Yeah.
So I am eligible to minus your mark. Half of the mark I will minus. Okay. So if let's say you are 10, I will minus half. That is compulsory mark, half. So another half is what is based on what you have given me. Okay. So one, no plagiarism.
How much percentage?
I think it should be 20. I will give you a detail later.
Okay.
Okay, I will give you a detail. I will text you or email you guys, okay? Okay, I will email you guys later. I will email, or maybe I will upload in the e-learn, the format that I want.
Yeah.
With the plagiarism, what is the percentage and everything, okay? So first, you have to have an introduction. You have to have a flow chart of your method. So now, if you do nanostring, you use nanostring as a platform for the biomarker sample collection. So the sample collection, you collect sample from where? Is it tissue? Is it where? So you must know all that, okay? And then you must have a flow chart. So I want to have a more schematic diagram. I don't want to have too many words. Don't give me too much words. Do a diagram. Okay, represent your flow chart in a diagram. You got what I mean? And give it to me. Okay? Another thing, you must have an advantage and disadvantage. What is the advantage of this platform? What is the disadvantage of this platform? You must have all these 4 components in your write-up. You don't do any of these components plus reference, your marks will be deducted.
Okay.
You must have 5 components. Introduction, flowchart, advantage, disadvantage, reference.
Okay.
Okay, and make sure reference is up to date, not cite 90 reference. Don't cite 80 reference. Doctor, I want to use the original, those days, Asian reference. I don't want. Must be updated 5 years. The 5 years, recent 5 years. At least, the recent 5 years, you use the recent 5 years. So now I know that you are get updated. At least you must have 10 reference. Okay. So what you have to do, pick an article that you are interested based on the platform that I have given you. Okay. Now you have to do a review of that article by referring to another article. Why are you referring to other article? That article may give you using a nanostring for to do the disease, but they never mentioned about the advantage of this nanostring. So you have to refer to other articles. So the other article. When you pick article, you are doing on cancer research, breast cancer. They don't give you much introduction on the breast cancer. You refer to other article on the breast cancer. Cite that article. You get what I mean? Okay? So do a citation properly, do a reference properly, and no plagiarism. Okay? I understand? Question.
Biomark discovery, like for example, like my platform, I have to choose one disease too. Like for one disease, biomarker. By
Yes,
platform.
see, one disease. Transcriptomic, don't do proteomic. I don't teach you guys proteomic. Suddenly you present doctor, I want to
Interesting.
please. Transcriptomic, okay? Transcriptomic, it can be any disease related to transcriptomic, not related, not necessarily cancer. You can do anything. You can do gastric, you can do anything. Heart problem, heart attack, anything. Up to you. Okay? So when you do a presentation, when you do a report, you do a discovery, right? So in that report, you have to tell us the validation. How do you going to validate the biomarker? If you choose a paper that don't do validation, they just do discovery, you have to propose the validation. Okay?
Or if they don't do validation, you have to propose the validation.
You have to propose the validation.
Then there's no reference already.
Then that's why you have to read. This is the research. So when you do research, you have to propose. Like my student, I do spoon feed. I always ask them to go and read and propose to me what they want to do. So this is part of the training. Okay, I ask you to do validation. Okay, they tell us these are the marker that they discover. So you validate. How are you going to validate? Use a platform to validate. So how do you going to use a platform to validate? Lebih kurang lah design, more or less.
So the validation, it can be different platform.
Of course, it has to be different platform. Validation has to be different platform.
So today, if I'm doing RNA sequencing for biomarker discovery, so the validation would be RTP.
Biomarker validation can be any platform other than this also can be.
Out of these three.
Right, like real-time PCR is also a validation.
Every time is
Usually people just go for real-time PCR because it's cheaper.
yes.
You already spend so much money for discovery, you don't want to spend so much bunch of money
Validation.
again for the validation. And validation, usually people do real-time PCR because they know already these are the gene that they discover. They just want to validate this gene. They can design the primer already for those genes. So they use real-time PCR. But you can also use other platform you want. If you are rich, you can, why not? Okay? Any question about the assignment? The submission?
About details about the validation platform.
So you have a discovery, you have a validation.
So
In your flowchart.
validation should have to be detailed or no?
Yes, you have to have sample collection, how you validate, and then what are the expected. You got what I mean or not?
Yeah.
It depends on the article that you choose. That's why I say it depends on the article you choose. If you choose the article that already have a validation, then you just summarize that. If you want to be extra creative, no doctor, I don't want. I just want to have my own mind in this. I want to propose something. Then you propose. Means you propose me, you have to propose a proper one now.
Okay.
How do you validate? Not just I validate using real-time PCR, doctor, huh? What is this? I mean, not to the extent you have to design primer. But tell me now, what are the genes that you're going to validate? You got what I mean, no? These are the genes that will be validated and primer will be designed accordingly. That's it, lah. You understand?
Yep.
Question?
No.
Doctor,
Yes.
so we need to prepare a report,
Yes.
also present a slide.
Yes. So the report will be your assignment report. I will mark your assignment using the written report. Okay? So that is where I will use rubric. You have rubric, right? I will upload the rubric later. So what are the rubric I will use for the assignment? That will be only for written assignment. Presentation will be the tutorial that we're going to do because my class is tutorial class. We're supposed to have discussion. So we're going to have discussion from your presentation.
Okay.
From your presentation, I'm going to ask you. You all have to ask question and we're going to have interaction. So it's going to be very useful because you are the one that presenting, right? So you capture in your brain the method. Okay? So later on, you have to upload in e-learn. It's an evidence for the audit purpose later. Are you clear? The other side? Hello? Okay. I think so. Any question?
So it's for like for validation, like we would validate the biomarker that we have found this with the platform.
Yeah.
With another platform.
Another platform. Validation has to use different platforms. So yeah, I got the important for it. You understand? Okay, come back. I need to finish my class. Later you can discuss. Later you guys can discuss. Okay, we just finished the class because I have 3 more slides to go. Then we can end our class today. Then we can do the discussion. Okay. So this is the process. You see. Okay. I just take one picture of you guys, cannot. My son has habit. He don't want to eat if I don't feed him.
Need to pay.
So he's asking where I am. He doesn't want to eat. Can you imagine? Since lunchtime he didn't eat. Now dinner also he don't want to eat.
Beat her ass. Beat his ass. Take the belt.
Okay, so biomarker discovery process, development process. We have a discovery, analytical validation, evaluation of clinical utility, and also we have a clinical use. Okay, so these are the steps of biomarker development process. Discovery. When you want to discover a biomarker, you have to identify what are the sample size, the biospecimen. Okay, the biospecimen.
Specimens.
Yeah. Okay,
Specimen.
so you must have that from, okay, you want to study that expression from where? Is it from tissue? Is it from the blood? Like, you know, that's why it comes to the earlier lecture. You must know the type of biomarker that you want. If let's say you're working with microRNA, then you just withdraw the patient blood. Give me your blood. Enough. If you want to work with other type of biomarker, you might need this tissue. So you have to do biopsy. So it depends. You have to really identify specimen. The biomarker is actually high abundance, low abundance in which sample. Okay, that's one thing. The cell line biopsy, or you want to get the sample from a patient that already ongoing clinical trial. Okay, what is it? It means if when you want to identify, but when you want to do a discovery, you have to identify a group of population. Okay, like now I want to do biomarker discovery for breast cancer. Okay, so I want to identify 500 patients that has breast cancer. I want to group them as a population for my study. Faham? Okay, so this 500 patient or 500 sample, it has to be one representative of your population. Representative of your population means that when I study in Malaysia, okay, if I study in Malaysia, I want to say biomarker discovery of breast cancer from Malaysian population. That's your title, Malaysian population. Malaysian population means what? You have to be representative of Malaysia. Malaysia, how many ethnics we have? Malay, Indian, Chinese. So your sample population should represent all these 3 ethnics. So when you do a biomarker discovery, you must have an outline. How you want to discover your sample? How you want to collect your sample? One is it has to represent your population. Okay, it has to represent the ethnicity of Malaysia. Another one more thing, it has to represent a geographical area. You cannot just get everything from Kelantan and you say it's Malaysian population. Kelantan people eat sweet, you know. Everything is sweet. So their expression profile in their body could be slightly changes or slightly different than people in Penang. We used to eat nasi kandar here, all spicy. So the environmental factor, right? Food is your environmental factor. So the food environmental factor could affect the expression profile of your gene. You get what I mean? So when you do a sample collection, it has to represent the geographical area of population. You have to get some from the east, some from the west, north, south. Then only you can put representative of Malaysia population. That's one thing. Another thing, you must know your patient. What is your patient ongoing? Is it ongoing any clinical trial? Can you pick somebody who is already ongoing clinical trial to be your patient? because they already have some drugs taken in them, right? So they could affect the expression profile of basal individual, of normal individual that is not undergoing clinical trial. So you have to omit those people. Can you take a patient that has diabetes, that has other underlying disease? Cannot, right? You have to get a patient, you have to, that's why I say clearly identify your patient. When you do a patient, by discovery, you have to clearly identify your patient. This patient only breast cancer, cannot have any other disease. Okay, so you have to check all that. You have to, that's why they give you a form, you have to, clarify that you don't have this, that disease and all that. Okay, that's one thing. So cannot enroll ongoing patient, that patient from the ongoing clinical trial. Specimen must be collected from the large population involving clearly defined set of patient. I said, right? Clearly defined set of patient means that this patient is this. This patient is that. Then you group that as a sample for your case study. The sample must be large enough. Let's say Malaysian population. What is the Malaysian population size?
Sorry. Now?
What is the Malaysian population size now?
30 million plus.
Okay, so if you have 30 million population, you take only 300 samples, do you think it's representative of your population?
No.
No. You have to get a sample that is representative of your population size. How do you want to know that? You have to statistics. You have to do statistics for your sample calculation. That is a sample calculation statistic that you have to do. You have to key in the information and all that. Then they will come up. What is the expected size number that you must have so that it represents your population? Okay, so this, what I mean is, the sample must be large enough to cover your population. Then only you can announce it, or you can say this is a biomarker discovery for population. Okay. Okay, and it has to take cost. How long the sample. If let's say you are working with the archive sample, sample that has been stored, right? Some of the sample we store in the fridge, in the freezer. You have to take into account. Do you want to work with the fresh withdrawn blood, or you want to work with the blood that has been stored in the freezer? You cannot. It's overlapping and everything. If let's say fresh blood, all must be fresh blood. You cannot work with archive sample. If let's say archive sample, then you have to clearly identify the archive sample has been kept for how long. You cannot work with maybe more than 1 year sample. It's within 1 year. It has to be clearly defined. Okay, I already said it must reflect the. I think I have to use this one for the other side. It must reflect the patient population. Post-sample handling. What is post-sample handling? You are working with RNA. RNA is very degradable, easily degrade. And then you handle them without care. Sometimes you do that. That's why you must have a clear SOP. How to handle your sample means that the process time should be 10 minutes, cannot be more. It has to be on ice, all those things. So you must have a clear SOP how to handle your sample. Okay. Storage, collection, processing, how you collect from the patient, which tube you're gonna use. You have to use the same tube from the same company. Cannot like from Kelantan you use from Sigma. You go to Johor you use Merck. Cannot. It has to be uniform. Okay, and then okay, this is what I said. Validation are needed. That's why I mentioned already, right, in the assignment. When you do a biomarker discovery, you need a validation using independent sample set, which means that now that's why everything is actually based on statistic. When you use a statistical analysis to calculate your sample size for your discovery, you use statistical analysis to calculate sample size for your validation. It might not be the same population size, it can be smaller size for the validation. But there is numbers that you have to know from the statistical analysis. Okay? So from there, once you do a discovery, then you can confirm or reject the potential biomarker. Pre-analytical, analytical, I mentioned, the sample, the storage, the processing, all can affect the outcome of the biomarker. Okay? It's necessary to assess, okay, these are the matter, validate, okay, I've mentioned already, okay, clinical validation. So clinical validation, once a technical assay has been developed, biological marker must Okay, clinical validity. Okay, what is clinical validity? Which means that now you already discover, right, biomarker. This biomarker can clearly identify or classify two groups of patients. You know, which means that biomarker reliable to divide a population into two groups: likely to have, no likely to have, can have, no. You get what I mean? So that strong your biomarker should be. Means that when you now have 5,000 sample of patient, all that 5,000 should produce you the result. Okay, if let's say one or two doesn't give you the result, means that that is not biomarker that you want. You know, then it's not only that 5,000. When you do a validation using a different set of sample, that validation also should produce you the same result that you want. Then only you can say as this is a potential biomarker. It's not a biomarker yet. It's a potential biomarker. Okay. Then what do you mean validity? It can clearly divide two groups. Okay, this biomarker. Clinical need to be reproduced. Okay, this is what I meant. Clinical validity means you should be able to reproduce the result using an independent sample. That's why I said clinical validation. Clinical validation is important because when you validate, you use a independent sample. You don't use the same sample again. It's a new group of people.
Reproducible result.
Yes. Okay, that's where it comes to clinical validity. Clinical utility, you know, once you already discover, you validate, then only you will know whether it's potential to be utilized as a biomarker or not. So, clinical validity implicate the patient management, you know, then it goes, you know, when you use this biomarker, can it implicate the patient management? If you develop this biomarker for the prognosis, for the, you know, discovery of the treatment or anything, you know, you have to study on that as well. Inappropriate clinical utility may harm the patient. Inappropriate treatment selection. You know, when you have not a solid biomarker, it can, of course, affect the same patient. Very few clinical biomarker has been established, like KRAS for the colorectal cancer, for the development of anti-EGFR therapy. So very few. So once you already have a biomarker, it has to go through. You already discovered, you already validate, you already did a validity, utility and everything. Now it has to go through regulatory approval. Regulatory approval is according to the country. Malaysia has a different regulatory approval compared to US. So you have to go your country regulatory approval. You know, you have to go through to get the regulatory approval and whether it can be commercialized or not. It depends. If it's a commercializable, and then you have to go for patent, trademark, you know, and how you want to commercialize that, and whether it can be incorporated into a clinical guideline. So the application, disease diagnosis, you want to see the effectiveness of the drug, and all those things I have covered. This I have covered. No, I won't go through details of this step because we're going to discuss that in our next lecture. Okay. Okay, these are the type of example of the paper that you can use. you can search. You know, using microarray based subtype method for breast cancer. Your era of high throughput RNA sequencing. You know, these are the type of. You might get a bit confused, you know, when you go for literature because there are so many and you don't know what you want. So I suggest you have to narrow down. You want to work with nanostring on what? Is it breast cancer? So you search only breast cancer nanostring. So it doesn't just come out everything and you confuse. Okay? You have to narrow down. So the other aspect of transcriptomic beside discovery of a new biomarker, we can also use that for the risk assessment purpose, which means that we want to see the expression profile of this transcriptomic in relation to the toxicity. You know, whether the particular exposure of a drug, of a chemical is toxic or not, you know. So you see gene expression, chemical structure, you want to see the toxic of the drug. Like for instance, they have done a toxicological study on a triazole exposure. So when you expose to a particular chemical, you know, there is a changes in the transcriptomic profile in the body. So that can also be used. Means transcriptomic not just for the biomarker discovery for the disease, it's also for the response of a response of the toxic material. Okay. So these are another example that you can go through. I just give you the example. I will upload this slide so you know you have a bit of idea what type of research paper that you can search through. You know, discovery, and you can see in this method, I already mentioned to you, right? If you don't have validation in your paper, you must do validation in your report. But if you have, then just follow the paper. Like this one, discovery and validation. So they have a discovery and validation in this paper. So you just mention in the report. Report is a review, It's like a review you do.
Yep.
Don't just copy. You have to understand why they do this and everything, and just put it in the diagram.
Yep.
Okay?
Thank you.
Thank you.
Thank you.
Finally.
Oh, it's before 8. Oh, it's
So any question? Oh, it looks like you all can't just wait to leave.
No, because we still haven't processed the information yet. It's not, I have to deeply process only the time that the question.
Do you think I cover too much, too little?